Dear children, in the previous class we studied about the distance of closest approach. Similarly, another important term in the alpha particle scattering experiment is impact parameter represented by the letter B. So, what is the definition of the impact parameter? It is the perpendicular distance of the velocity vector of alpha particle from the center of the nucleus. See this figure here, this is the nucleus and this line represents the center of the nucleus. And here an alpha particle, when it passes very close to the nucleus, due to the repulsive force, it deflected through an angle theta. So, the perpendicular distance between the trajectory of the alpha particle, which means the path of the alpha particle, or we can say that the velocity vector of alpha particle from the center of the nucleus is known as the impact parameter B. And in the alpha particle scattering experiment, you studied that there are three types of particles are there. First one is undeflected particle, second one is deflected particles, and the third one is rebound particles. So look at this figure. The first line represents the undeflected particle. So this alpha particle is at a very large distance from the center of the nucleus. That is, B is large. Why this particle is undeflected? Because the repulsive force is weak. Because the alpha particle is at a very large distance from the center of the nucleus. So the repulsive force is weak. So the particle is undeflected. So we can say that the B is large. So when the B is large, what is the theta? That is the scattering angle, theta equal to 0 degree. So this is the undeflected particles. In the second case, see this line. So here the alpha particle, when it reaches very close to the nucleus, due to the repulsive force, it deflected through a scattering angle theta. So that value must be 90 degree, 60 degree, 50 degree and so on. So in this case, the B is small because the alpha particle is close to the nucleus, close to the center of the nucleus. So the B is small and the repulsive force is large. And in the third case, the alpha particle, when it reaches to the center of the nucleus, due to high repulsive force, it rebounds with an angle of 180 degree. So in this case, what is the value of B? B equal to 0 because the alpha particle is close to the, that means it reaches to the center of the nucleus. So the perpendicular distance from the center of the nucleus for the rebound particle, that is equal to 0. In this case, the scattering angle theta equal to 180 degree. So in the examination point of view, this is very important one. From the alpha particle scattering experiment, Rutherford suggested the structure of atom. First one is, there is a positively charged center in an atom called nucleus and all the mass of the atom resides in the nucleus. Number 2, the electrons revolve around the nucleus in circular path. And number 3, the size of the nucleus is small compared to size of the atom. And the fourth, the atom as a whole is electrically neutral. Watch the next video for the limitations.